Cows fed feed containing hemp produce enriched milk. Cows eating feed containing hemp showed typical symptoms of being under the influence of psychoactive substances. They had red eyes, an unsteady gait, and were drowsy. Studies have shown that psychoactive compounds from cannabis can persist in cow's milk, but their possible effects on humans remain unclear. Scientists report that cattle that ate feed containing hemp appeared to be under the influence of psychoactive substances. New research may be an important voice in the discussion on whether inexpensive, fast-growing plants are safe for farm animals. Experts also have concerns about whether the active ingredient in marijuana could find its way into human food through the milk of cows fed hemp. The behavioral effects documented in the new study are noteworthy, said Serkan Atas, an agronomist at Oregon State University in Corvallis, who studied hemp consumption in cows, lambs and chickens. The impact on animal behavior turns out to be much deeper than observed in previous studies, he explains. Hemp, Cannabis sativa, has a lower concentration of the psychoactive compound tetrahydrocannabinol, THC, than Cannabis indica. Instead, they have higher concentrations of cannabidiol, CBD, a chemical that scientists have linked to alleviating many health problems such as pain, anxiety, addiction and insomnia. Additionally, flexible hemp fibers can be used to produce, among others, clothes, shoes, paper and biodegradable plastics. In recent years, there has been a rapid development of hemp cultivation. However, the U.S. Food and Drug Administration, FDA, has not yet approved feeding cows with this widespread plant. All because of concerns about THC getting into food. To check how cannabinoids, including THC and CBD, from hemp affect animals, scientists from Germany fed 10 dairy cows different amounts of hemp feed containing different concentrations of cannabinoids. During the several-week experiment, researchers collected milk, blood and feces samples and paid close attention to the cattle's behavior. Scientists found that the doses of psychoactive substances consumed were crucial to the cow's behavior. Cattle that ate fermented feed prepared from whole hemp plants showed few noticeable behavioral changes compared to cows fed a normal corn-based diet. This was not the case with cattle, which ate feed prepared from cannabinoid-rich hemp leaves, flowers and seeds. According to scientists' calculations, these cows absorbed up to 86 times more THC than needed to reveal a clear effect of psychoactive substances on humans. In this group of animals, a slowdown in heart rate and breathing was observed, as well as a reduction in the amount of food consumed and milk given. Moreover, the stoned cows were disoriented, yawned more, and produced more saliva and other secretions. Some individuals had red eyes and were unsteady in movement. The unusual behavior in the animals stopped several days after the cattle stopped eating hemp. Despite this, cannabinoids remained in cow's milk for some time. Scientists are not sure whether consuming milk, enriched with THC and CBD could lead to changes in human behavior. The study does not allow any conclusions to be drawn as to whether there is a health risk from consuming such milk, says animal nutritionist and study co-author Robert Pieper. If such milk turns out to be safe, hemp would be a welcome addition to farmers' feed, says Atas. Hemp is a cheap, widely available and nutritious alternative to other feed. It may not be possible to feed it to high-yielding dairy cows, but there are plenty of other options to explore. such as feeding hemp to non-food producing animals such as heifers or young lambs, the researcher said. Previous research also suggested that hemp-rich feed may calm animals. This can be helpful in relieving their stress, for example during transport. Scientists have built an artificial finger covered with skin from human cells. Japanese scientists have built a robotic finger covered with living, skin-like tissue. This substance is hydrophobic, can regenerate itself and has the consistency of our own skin because it actually consists of human skin cells. The largest organ ceases to be the domain of living organisms. It's about the skin. Of course, everything indicates that we will soon have to extend our thinking about skin to robots. What is even more important? This time there is no artificial leather. Scientists from Tokyo have developed a substance consisting of human skin cells that they covered with a remotely controlled robotic finger. This coating grew on the finger. It was not grown separately in the laboratory. The authors of the invention claim that their skin can change the approach to humanoid robots covered with it and make them indistinguishable from humans at first glance. The description and results of the research were published in the journal Matter. The work on the skin was carried out by a team of scientists led by Shoji Takeuchi, a professor at the Department of Mechanical and Biofunctional Systems at the University of Tokyo. Unlike other projects of this type, it is not artificial leather, but to some extent real. A mechanical finger was used in the project because, on the one hand, its elements are already well known and tested for their operation, and on the other, because fingers are crucial for the functioning of robots for many reasons. Scientists tried to give the new skin the characteristics of human skin, including its structure. At the very beginning, the robotic finger was immersed in a solution of collagen, the most important component of human skin, i.e. fibria or fibrous protein, and human fibroblasts. Let us remind you that these are also important building blocks of human skin. Then, they waited until the applied layer of solution, tuned, to the appearance of the finger. The next step was to use human keratinocytes. In the case of human skin, they are responsible for the production of keratin. It is also thanks to them that the cells of our epidermis, our outermost layer of skin, are created. The finger in question was therefore equipped with layers of skin partly corresponding to human ones. It is also worth emphasizing that the finger could move completely freely in such skin, so it is a step in the right direction. Equipping robots with skin similar to human skin will significantly increase the capabilities of robots. First of all, it will be easier to play. Already during the research, it was noticed that in case of skin damage, it was enough to apply a collagen bandage to the mechanical finger, which allowed the damage to heal. The new skin will certainly give robots new possibilities when working with wet materials. The next issue is of a purely practical nature. Imagine that a robot's skinless fingers are trying to grasp a cup. The material the fingers are made of is hard, just like the cup. This means that catching the cup must be extremely precise, including in terms of the selected force, because even a small mistake can lead to its destruction. However, if the robot's hand were covered with leather, the margin of potential error would be increased because the leather would absorb the pressure. The team of scientists plans to continue working on skin for robots. First of all, so far it is not possible to be 100% sure yet. say that the skin is alive. It is not nourished by anything, nor is it able to remove used cells like human skin. Therefore, it is not fully self-sufficient. That's why Shoji Takeuchi is thinking about equipping it with a kind of equivalent of the vascular system. There are plans to make it even more similar to the human one by adding elements such as nails, hair follicles and even sweat glands. Intriguing ripples have been detected at the edge of the solar system. A team of astronomers has detected folded structures in part of space at the edge of the solar system. The analyzed data suggest that the heliosphere, the area around the Sun where the pressure of the solar wind prevails over the galactic winds, is constantly changing its shape. The research also indicates that it is possible to obtain a detailed picture of the boundary of the solar system and how it changes over time. All objects in our solar system are surrounded by a protective mantle, produced by our Sun, the heliosphere. This bubble of material constantly ejected from the Sun protects planets from harmful cosmic radiation by blocking high-energy particles that originate in interstellar space. At the edge of the heliosphere, the solar wind loses its speed, and the pressure of the galactic winds begins to outweigh the pressure of the solar wind. This boundary is called the heliopause. This is where the solar wind collides with cosmic rays. However, not all particles from interstellar space are retained. Some of them penetrate into our planetary system. Previous research has also shown that there is a point at the edge of the solar system where the solar wind slows to subsonic speeds. This is called the terminal shock. Researchers have been trying for years to determine what the shape of the heliosphere is and where exactly its boundaries are. But why worry about its shape? Scientists studying exoplanets are keenly interested in comparing our heliosphere with those around other stars. We know nothing about whether the solar wind and the heliosphere can contribute to the emergence of life. Scientists are still working out what exactly the Sun's protective bubble means for life on Earth. It certainly protects us from particles from interstellar space that could damage our DNA. But these particles can also be good for life. They can cause mutations that allow organisms to evolve, making them more complex. In a paper published in the journal Nature Astronomy, a group of astronomers described their analysis of data from the Voyager 1 and 2 probes that crossed the heliosphere boundary, Voyager 1 in 2012 and Voyager 2 in 2018, providing us with the first in situ measurements of this changing boundary. Researchers also used data from the Interstellar Boundary Explorer, IBEX, which orbits Earth, to obtain more information about the nature of the heliosphere. IBEX measures high-energy atoms created when the solar wind collides with galactic winds. The researchers carefully analyzed data from these three sources. They show that in 2014 the pressure of the solar wind increased by about 50%. Scientists used this to study the shape of the heliopause and terminal shock. Because some atoms managed to escape into interstellar space and others were reflected back into the solar system, scientists were able to use the collected data as a form of cosmic echolocation. During modeling, they found that huge ripples had formed in the boundary areas, tens of astronomical units in size. 1 astronomical unit is the average distance between the Earth and the Sun, approximately 150 million kilometers. Astronomers also found large changes in the distance to the heliopause. Voyager 1 crossed the heliopause at a distance of 122 astronomical units. In 2016, the team measured that the distance to the heliopause towards Voyager 1 was approximately 131 astronomical units. At that time, the spacecraft was 136 astronomical units from the Sun. Similar measurements taken for Voyager 2 showed that the spacecraft crossed the heliopause at a distance of 119 astronomical units. Both measurements suggest that the shape of the heliopause was not uniform and that it was constantly changing for unknown reasons. Scientists hope to learn more about the boundaries of the solar system using data collected by the probe, which is scheduled to be launched into space in 2025. It is intended to explore the space near the boundaries of our planetary system and perform measurements with much greater precision and in a wider energy range. This, the team says, should help answer some of the perplexing questions about the heliosphere. There is much more magma beneath Yellowstone than previously thought. As we know, Yellowstone is not only a beautiful and vast American national park. Beneath this area is also the caldera of one of the largest supervolcanoes on Earth, the eruption of which would have catastrophic consequences for the entire globe. In this context, knowing the exact amount of magma stored under Yellowstone is crucial. Supervolcanoes are defined as volcanoes that have had at least one explosion of magnitude 8 on the Volcanic Explosivity Index. This is the highest position in the indicated index and is attributed to the largest volcanic eruptions in history. This means that the explosion released over 1,000 cubic kilometers of pyroclastic material, and the height of the dust cloud thrown into the atmosphere exceeded 25 kilometers. The Yellowstone supervolcano had the most such explosions. Scientists know of 5 eruptions of this type of the American supervolcano, and the last one took place approximately 640,000 years ago. The Yellowstone area is not a quiet place. Scientists constantly record earthquakes there. They are not strong, but when activity in the volcano's caldera area increases, there can be even hundreds of them in a week. More disturbing information about the supervolcano has recently emerged. Scientists have shown that there is up to twice as much magma under Yellowstone than previously thought. Does this mean that the volcano is getting ready to erupt? This is not known. Predicting an eruption is extremely difficult. However, if the supervolcano erupted, the results would be catastrophic. But scientists reassure us and say that there is no reason to worry. Determining how much magma has been stored under Yellowstone is important because it may, in part, determine how imminent an eruption of this supervolcano is. Incidentally, it is often said in its context that, considering the cyclicality and frequency of its eruptions, this volcano is a bit late. But how can we determine exactly how much magma is there? One of the possible imaging methods is the so-called seismic tomography. For this purpose, ground vibrations, i.e. seismic waves, are used to create a three-dimensional image of what is happening under the Earth's surface. Using this method, Ross McGuire, currently employed at the University of Illinois Urbana-Champaign as an assistant, managed to image a network of magma chambers, also revealing the location of the magma itself. However, these images were not accurate. An even better method was needed. McGuire consulted his results with Min Chen, a late expert in a type of computational seismic tomography called waveform tomography. The combination of her abilities and the images he obtained brought the expected results. By joining forces, scientists were able to better model how seismic waves propagate. Thanks to this, it was also possible to significantly improve the quality of the results obtained by Maguire. In this way, we learned much more about the magma accumulated under Yellowstone. What is important here is the summary of this issue by the mentioned researcher himself, who stated that it was not so much possible to see the increase in the level of magma, but rather to see more clearly what was already there. The magma chamber contains a mixture of molten rocks and crystalline structures. The more molten rock there is, the greater the risk of an eruption. Previous research indicated that the chamber contains about 10% magma. Improved imaging allowed us to see that there is actually twice as much magma there, from 16 to 20%. Previous estimates were about 900 cubic kilometers of magma in the reservoir. The new ones indicate 1,600 cubic kilometers or even more. Ross Maguire, however, reassures that this does not mean that an eruption may occur in the near future. He emphasizes that the network of geophysical instruments that constantly monitor the activity of the supervolcano under Yellowstone will certainly warn us about this. Scientists estimate that an eruption may occur when there is 35 to 50% of molten rocks in the chamber. Our ancestors dressed in bear skins 320,000 years ago. According to research by German archaeologists, our ancestors date back 320,000 years. Years ago, they hunted cave bears to obtain their skins, which served as clothing. This is evidenced by precise cuts on bones found in one of the caves in Germany. New research shows that our ancestors in Northern Europe were able to survive harsh winter conditions in part thanks to the warm skins of bears. As we know, our prehistoric ancestors hunted various species of animals. However, the main reason for this was not always the desire to obtain and eat their meat. Bears can serve as an example here. Because our ancestors cared much more about their fur. A bear's winter coat consists of both long outer hairs, which create a breathable protective layer, and short, dense hairs, which provide particularly good insulation. According to German scientists, bear skins allowed our ancestors to survive in the cold and harsh conditions of northwestern Europe in the Middle Pleistocene. We all probably agree that traveling without any clothing in winter on our continent would not be a wise idea, to put it mildly. Our 320,000-year-olds probably had the same opinion. Years ago, the progenitors, scientists claim that they have found evidence that they used the fur and skin of hunted bears to protect themselves from the cold. One such piece of evidence is worth noting. At the archaeological site of Schöningen in Germany, dating back to the Stone Age, traces of cuts were noticed around the paws of bear remains found there. Interestingly, similar evidence has also been found elsewhere in Europe, but that from Germany is by far the oldest, dating back approximately 320,000 years. The site in Schöningen is also unique for another reason. It is here that the oldest spears discovered by archaeologists were found. So it is extremely important in the context of research on hunting animals by prehistoric people. The cut marks mentioned above usually indicate that people obtained meat from a given animal. However, as researchers point out, it cannot be cut from this part of the bear's body, its paws, in too large quantities. Therefore, it is more justified to assume that the purpose of such action was to obtain leather. Moreover, It must be taken into account that the animal's skin can only be used as a covering if it is removed within a day of its hunting. After this time it simply starts to deteriorate. Our ancestors could not simply look around for dead animals, because their skins were simply useless to them. Additional proof that the animals found in Schoningen were hunted is the fact that only bones and teeth of adult bears were found at this site. At the site in Schoningen, various types of tools were also found, the use of which was usually associated with the preparation of animal skins, such as scrapers. This, in turn, additionally strengthens the hypothesis that bears were hunted for their skins hundreds of thousands of years ago.